In this video you will see how you can repair a broken carbon fin mast. It can be done but requires a lot of time and patience. So many thanks to Easy Composites who did supply all the materials used for this repair. They also have excellent tutorials that describe how to handle the carbon and epoxy. This mast was broken just above the mast ring. That place is quite vulnerable due to the high strains on this particular location. So the first thing to do was to remove the piece around the mast ring so that we have clear cuts at both sides. Here you can see the buildup of the mast sideways. It is very thick with 11 millimeter of thickness, and fore and aft are quite thin, so 3 or 4 millimeters. And what we will do is we will try to rebuild this thickness to achieve the same level of stiffness, because that's quite important to keep it as it was. Now, to support the carbon and epoxy, you have to put something inside to support, because the carbon and epoxy are wet. So the best thing to do is to design an inside mold that is just fitting inside the mast. This was done and printed with a 3D printer. The next phase, which is very important, is to use a belt sander to remove the carbon and to achieve a number of steps. So that means that we can put the different layers on the different steps, and we are kind of spreading where the material is attached to the original mast. Please note that the last step is only like 1 or 2 millimeters, so really thin. What you see here is the mast with the mold, and we also added 2 millimeter thick carbon strips to increase the strength and the stiffness sideways of the mast. Please note that you have to be very careful up front to ensure that both pieces are very well aligned. You cannot see it on this picture, but we have used like strips in order to ensure that everything is really fixed in this wooden mold, so that things cannot move, and you have to make sure that everything is very well aligned, definitely sideways. So now we have to wait until the epoxy is dry for the next step. We now start to add layers of carbon and epoxy. So the first layer is quite short because we are covering only the first step. So we add like 3 or 4 layers, and we use shrink tape and a heater. This is required in order to push out the excess epoxy out of the layup. You can easily remove the shrink tape after 3 hours. If you wait longer, it's becoming really hard. But after that, the epoxy has to dry further. And once the epoxy is dry, you can go to the next phase. So we did this in like 7 different phases to achieve the final result. Also note that the carbon material we used is unidirectional to ensure that the fibers are well aligned with the direction of the stress. In this picture you can now see the final layup. We also have sanded it, of course. We also do that during the different phases, but here it has been sanded a little bit. We added a layer of epoxy for the final finish, and we also added a mast ring on the correct location. Finally, we had to use like 39 layers of carbon at the sides and 13 layers of carbon at the fore and backside of the mast to achieve the same level of thickness. If you calculated it, approximately equates to the 3 millimeter thickness and the 11 meter thickness that we saw in one of the first pictures. Now it's quite important to do some temperature cycling because the material is only achieving its final stiffness and strength after a temperature cycling. So what we did here was to build a small oven. This one is made of insulation material and some duct tape in order to have a box that is very well closed so that heat cannot escape. And we have a small heating element, so that consists of a thermal element, a small ventilator, and we also have a thermostat to control the exact temperature. Now the only thing that you still have to do is to bake the mast. So what we did here was we baked it at 60 degrees Celsius for 6 hours, and that went quite well. Now the mast is finished, and as we repaired the area around the mast string, the bend of the mast itself is not impacted, but there was a risk that the tip deflection was impacted because of this location. So what we do here is to measure the tip deflection. For a fin mast, you typically do that with putting a 12 kilo load on the top of the mast, and the foot is locked into a stiff structure so that it cannot move at all. And then we measure the difference between without weight and with this 12 kilo weight. Here we measure a tip deflection of 510 millimeters, which is a relatively stiff mast. You have to do the same sideways to see what the tip deflection is there, but that test went well and the mast is within the expected range. So that means that our repair was successful. So the only thing that we have to do now is to test it on the water. So this was it. Thanks again for Easy Composites, for their material and for their great tutorials and manuals, and good luck if you have to measure, if you have to repair and remeasure your mast. Thank you.